surfaces. First we will begin with plane surface, then we will go for curved surface. Now as we know that liquid pressure varies with height, so we will deal with non-uniform distribution of pressure and force due to surface due to that pressure, liquid pressure or hydrostatic pressure. Now we will start with the plane surface, and we will start with this simple example. There is a vertical wall and force due to liquid pressure on a vertical wall. So this is sort of a vessel actually, or say tumbler sort of a thing with a rectangular wall, and this much is the weighted area. This much is the weighted area, and the liquid level is given as H, and the width is given to be B. This one. So we have to calculate force on this vertical surface due to the liquid pressure, the varying hydrostatic pressure. So as we know that this is the free surface of the liquid, this one. This is the free surface of the liquid, and pressure varies due to depth taken from the free surface of the liquid. So if the depth is H or Y, then pressure at a depth Y from the free surface is Y rho times G, if rho is density of the liquid. So we will consider a certain level Y. From the free surface, and here the pressure at this level happens to be small p is equal to Y times rho times G. So we will consider a strip, again a rectangular strip. So this will be the rectangular strip, this one. That's dy. That's the rectangular strip. So the width of this rectangular strip is same as the width of this wall, and force acts normal due to pressure. Force acts normal to this strip in this following way. So let the force be dF. dFy dF due to the small force, the small strip, finite pressure, so the force will be small, so dF. So dF is the force due to liquid pressure on the rectangular strip So as you know, dF is equal to pressure times dA. So dA is, so area of this rectangular strip is dy multiplied by the width. So dA, so rectangular strip of area dA is equal to Y rho G, which is pressure. Oh sorry, that's dA. Force will be dF. Pardon. So dA will be simply d multiplied by dy, and in the next step the force dF is equal to, so force due to liquid pressure on the area dA is given by dF is equal to pressure Y rho G times d dy. See, this pressure Y rho G is the pressure solely due to the weight of the liquid. We are not taking into account the atmospheric pressure, right? But if you calculate the absolute force, it will be atmospheric pressure. But if you look at the wall, this surface, okay. So the atmospheric pressure acts from the left side also and the right side also. So if you consider a small area, so absolute pressure P naught plus Y rho g times dA. This is the force due to absolute pressure at this point, and here to the left side it is open to atmosphere, so pressure is P naught multiplied by dA. So I think this now you know why this P naught is not considered here, because the atmospheric pressure acts from the left and the right, so ultimately it will have no effect, so that will cancel. Because see here I can keep my hand in this way because of this, so there is a huge atmospheric pressure acting on my hand from top and the bottom both, and that's not that less pressure. If I make this lower part somehow vacuum devoid of atmospheric pressure, and so immediately it will take fraction of seconds for my hand to crush, rather the bones will be crushed in no time at all. It's a huge pressure. P naught is 10 to the power 5 Newton per meter square. By the way, that is not taken into account, you know, because it acts from this side and this side, both sides. So only thing which survives here is Y rho g times dA. So dF is Y rho g times dA. dA is equal to B dy. So the net force on this vertical wall, so that's the vertical wall I am talking about, this one, right? So the net force on this wall will be net force on the wall due to liquid pressure is F is, now we add on this dFs, right? The force on this strip, so all this, consider these small strips like this, small rectangular strips, and you just add on the forces. That means you integrate over this dF, this quantity. So integral of y rho g times d dy. So y, the limits of y will be from 0 to h. So therefore f is equal to, so rho g b will come outside. So integral y dy, y square by 2. Now you put the limits of y from 0 to h. Now as you know we have to subtract this. So the force comes out to be rho g b h square by 2. So this is expressed in the following way also. I can write in this way: rho g h by 2, rho g h by 2 multiplied by dh. That is the force due to liquid pressure on the wall. See, so it happens to be, so average pressure, see rho g h by 2 is average value of the pressure multiplied by, so the force is average value of the pressure or mean value of the pressure multiplied by the weighted area. See, this much area is weighted by the liquid of area of width b and height h. So this rectangle, we consider this rectangle only, which is weighted by the liquid. So pressure is, force due to pressure is average pressure multiplied by the area. This is not the general formula, it works here as it's a rectangular surface. But in general the formula is, in a small while we will be deriving that too. The formula for force will be pressure at centroid of area multiplied by the area itself. This is the actual formula. Pressure at the centroid of this area, centroid of the weighted area multiplied by the area, weighted area itself. What is meant by centroid of area? Now you have a certain weighted area, that's a plane surface. Consider a uniform lamina of same shape of that of the weighted area, and just look at the center of mass of that lamina. That is the centroid of the area. That is known as centroid of area. So next thing we will discuss that if this is not a rectangular surface, then what to do, then how to calculate. This is the formula we have got, what we will derive.